What's up, everyone? Today we're going to be doing a math league test, specifically 12324, which is January 2023 qualifier round for mathleague.org, the elementary school contest. So it's a lot of words that I just said, but essentially mathleague.org is like a contest that mimics math counts. I think it's definitely a good contest that helps prepare students for it. My brother took it last year as a fourth grader. He found the test quite challenging. Obviously, near the beginning, the questions are pretty easy, but the difficulty picks up pretty quickly. It was one of his first contests, so that's why I'm making this video, to kind of show that, even though the questions look a little complicated, there's obviously a simpler way to do it. I'm kind of rusty at math, so bear with me. And if you have any questions, feel free to put in the comments below. Obviously, for some of the more complicated questions, you can obviously check the solutions for better ways to do it. But sometimes it's easier to hear the solution verbally versus just reading off a page. So anyways, let's get started. We got 14 burgers in the morning, 25 in the afternoon, 16 in the evening. How many did Eugene cook in total? So that's pretty simple. It's just addition. We can just do that real quick. Should be 55. Nothing too complicated there. What's the largest answer choice with no odd digits? So this one has an odd digit. Process of elimination. Now, which one's the largest out of all of them? This one, right? This one. Okay. Michael has a few whole bundles of sticks, each of which contains 12 sticks. So the trick is, don't read the full question, just read the first part and then read the question part, and then you're done. Right here, I can just decipher that the answer is going to be a multiple of 12, right? Multiple of 12 meaning it's got to be 12 times a whole number, right? So this one cannot do that. This one doesn't do that. This one doesn't do that. This one doesn't do that. So it's got to be B. Already got through the first three questions. We can literally see all this information here, so I'm not going to read it out loud. What is the area of the rectangle, the smallest area? Just multiply them. We know that area is equal to base times height for a rectangle. If you do not know that, please remember this. I know there's a lot of people or a lot of students that tend to forget some simple stuff and then remember more complicated stuff instead. So it seems that our answer is going to be 4,200. Everything else is larger. Now, number 5. June 1st, 2014 was a Saturday. Matt departed for summer camp on June 29th, 2014. What day of the week did Matt depart for summer camp? So you can see that summer camp was 28 days away from June 1st. 28 days, right? And one thing we know is that every 7 days, we're going to be on the same day of the week, right? Like, if today is Tuesday, right, in 7 days, or in exactly a week, it will be Tuesday again. So essentially what's happening here, in 28 days, 4 weeks pass, perfect 4 weeks, no extra days, no less days than needed, perfect 4 weeks, evenly 4 weeks pass by. So it's going to be Saturday again. All right. Now, number 6, Marion is doing a jigsaw puzzle with all square pieces. Pieces that Marion has placed. What fraction has she placed? Just got to look at this really quickly. Instead of counting all of them, it's just wiser to find the areas of specific regions. Area of this is 20. Area of this is going to be 8. Area of this is going to be 42. Area of this is going to also be 8. Area of this entire thing So we could see 7 here, 8 there, and then 10 there. So there's 150 in total, right? All right, and shaded is how many she already placed, so we're going to subtract 20 plus 8 plus 42 plus 8. So that's going to be 50 there, plus 28, 78. So that leaves us with 72 pieces that she's placed. What fraction is that? So the top and the bottom, you can divide 6 on top and bottom. And we'll get 12 over 25. What positive whole number is equal to 21 times the sum of its digits? I would suggest, honestly, for this question, when you're looking at it, you have 5 different choices. Might as well just add the digits and see which one works. So here, this is not going to work. It's 189. 15 times 21. Might work, might not work. Let's see if it works. It's 315, so that's not going to work either. 9 times 21, that's clearly not going to work. It's also 189. But this one seems quite promising. So 18 times 21. So that works, 378. That is the answer. No need to check the last one. Aiden and Carson each throw 2 darts at a dartboard, one at a time. How many ways can Aiden and Carson order their throws? So Aiden can go first, let's say. Then Carson can go first, then Aiden can go first, then Carson can go first. Or Aiden can throw 2 of them, then Carson can throw 2 of them. So the way I see it is that think of this like the 4 darts that are being thrown in total as like a 4-letter word, right? And the 4-letter word has 2 pairs of 2 letters that are similar to each other, like 2 A's and 2 C's. So how do we normally arrange letters in a word? We use factorials, right? So if we wanted to arrange the word cake, there'd be 4 factorial different ways, right? Which is 4 times 3 times 2 times 1, 24. But then let's say I were to change it up a little bit. Let's say I had cookie. This would be 6 factorial ways because 6 letters. But then since there's 2 O's, we'd have to divide by 2 factorial. Okay? Now, in this case, we have, let's say, 4 letters, right? So 4 factorial. Answer's 24, right? No, it's not, because there's 2 C's. So that's 2 factorial there, 2 C's there. But then we have 2 A's here, so we have to also multiply by 2 factorial again. So this becomes 24 over 4, which is 6. Now, of course, you could count it all out. But if you just have this in your head automatically and just think about it this way, you'll save like a minute or 2, and trust me, you will need that for the later questions. Okay, number 9. Justin and Elise perform 2 blah blah blah. Eugene calculates the longest total length in seconds. Okay. So this here is going to be 60 times 4. Because 60 seconds in a minute. 60 times 4 plus 14 is 254. There's a 119. There's 213. There's 185. So what's the total going to be? So of the 2, it seems that 398 is the larger number. So the answer will be 398. Tyler bought 2 dozen unpainted kendamas where each dozen costs $14. So if he bought 2 dozen and each dozen costs $14, that means he paid $28. I can tell you right there. He then spent $8 to paint all the kendamas, so then he has $20 left. What is the lowest price he can charge for each kendama to avoid losing money after selling all of them? Okay, so he bought 2 dozen, right? Each dozen costs 14. And then he spent 8, so we just said there's $20 left. So how much will he charge to avoid losing money? Obviously, he's going to charge the same amount that he... hold on. So how to avoid losing money after selling all of the... So I actually made a mistake. Since it's kind of late right now, I kind of messed up. He bought 2 dozen, correct? So if you bought 2 dozen, spent $28 there, but then he spent 8 more. So then in total he spent $36, right? So he spent $36, but he wants to get the $36 back. So he's going to divide $36 by 24 because he bought 24 in total. That's going to be 1.50 or 1 and 1/2, 1.50 that he's going to charge for each so that he can get back all the money that he lost and then break even, which basically means have a net, or how can I make this uncomplicated? Have a total change of $0, essentially. Okay. So, cool thing about checkerboards is that exactly one half of the checkerboard is shaded and one half is unshaded. And if that helps at all, you don't have to find the areas of all the squares. Just find the area of the entire square first, which will be 48 squared. It's going to be 48 to the power of 2 divided by 2. So what is that? 48 times 48 over 2, 24, should be 1152, if I did my mental math correctly. All right, we knocked out the first 11. We got 12. So how many whole numbers less than or equal to 100 are either divisible by 7 or have a digit sum divisible by 7? So we get a Venn diagram for this, because if I don't make a Venn diagram, I tend to count too much. So this is going to be divisible by 7. And then there's going to be digit sum. All right. So are there any that are both? Let's think about it. There's 7, 14, 28, no, 21, 28, 35, and since we're only doing less than or equal to 100, it's fine to count them all out. That should be all of them. So this one's definitely this one as well. I think those are the 3. And then besides that, how many other numbers are there? So there's 14 multiples of 7, less than 100. So that means this has to be 11. And then how many whole numbers have a digit sum of 7? No, digit sum divisible by 7. So first of all, we can either have a digit sum of 7 or digit sum of 14 and nothing greater than that. Because we can have a digit sum of 21. Because think about it, 99. The highest digit sum we can get is 18. And we can't get a digit sum of 0 either because we're looking at positive whole numbers. So this could be 70, 61, 52, 43, 34, 25, 16, and 7. And then for this, 77, 86, 95, and then just the backwards of 86 and 95. And that's pretty much it. So how many numbers is that? That's 7 plus 5, 12. But then this is going to be 3, or we're going to subtract 3 from that to get the numbers that, you know, are only, to get the numbers that have a digit sum divisible by 7 that aren't, like, the number themselves aren't divisible by 7. Sorry, I'm kind of losing track of my words right now. It's like almost 12 a.m. So, yeah, there we go. So 11 plus 3 plus 9. What does that equal to? 23. All right, 13. How many more votes did the first place candidate get than the second place candidate? So I'm going to do this really quick because all we really have to do is look at the two percentages that are biggest. There's two ways to do this. You can either multiply by 450 and then subtract the votes, or you could subtract the percentages, then multiply by 450. The reason why they're both the same is because distributive property. Or not distributive property, sorry, factoring. Well, yeah, both actually. Both of them are intertwined. So this becomes 2% times 450. Now we know that 2% is 1 over 50 or 2 over 100. This is the more simplified form of it. So then we get an answer of 9. Number 14. Thomas is playing a video game in which he can play 8 robot stages in any order. If Thomas wants to play the metal robot stage first and blah, 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 how many orders can he play the 8 robot stages? 1, 2, 3, 4, 5, 6, 7, 8. Metal first, air last. The rest of them can be arranged in any way that they want to be. But these two have to be set there. So these can be arranged in 6 factorial ways. Think of it as a word, right? So that's why the answer is 720. The rest of them don't, we don't have to really worry about arranging these because these are set in one place. Number 15, the number 25 over 111 can be written as a repeating decimal. So the thing about it is if you know some patterns, like 1 over 9 is going to be 0.1 repeating. 10 over 99 is going to be 0.10 repeating like that. 100 over 999 is going to be 0.100 repeating. So we can actually multiply by 9 on top and bottom to get 225 over 999. So that's going to be 0.225 repeating, which is really convenient because this is a repeating pattern, and we know that 2022 is divisible by 3 because we have 3 digits that repeat. So of course, we're going to have 2022 divided by 3 different cycles of that. I subtracted wrong. I feel so silly. So 674 different cycles. So 674 times 2 plus 2 plus 5 should be the answer. Should be 674 times 9. Now, I didn't actually need to do that. I didn't actually need to divide 2022 by 3. I realized just now that if I left it as a fraction, and then I knew that I was just going to multiply by 9, what's going to happen here is that I'm just going to get 6066. But of course, I found that out a little bit late, but that's fine. As long as I figure it out at the end. Becca is saying a sequence of numbers in which she adds a set amount to get from one number to the next. First number she says is 1/5, that's 0.2. Second is 0.3. So you can see she's going to add 0.1 each time. So you have to understand that after 2 numbers, she's adding 0.2. After 3 numbers, she's adding 0.3. So after 9,000 numbers, after 8,000, so think about it. For the second number, we're adding 0.1. For the third number, we're adding 0.2. For the fourth number, we're adding 0.3. So for the 9,000 number, we're going to add 8,999 times 0.1 to 0.2 there. So that's going to be 899.9 plus 0.2, which is 900.1. All right. How many positive perfect squares less than or equal to 1,000 have no odd digits? So if you just take the square root of 1,000, which you can't casually do, but you can find that there are numbers around it that are pretty close, like 31 and 32. 32 is the square root of 1,024. 31 is the square root of 961. So no odd digits. To have no odd digits, what does that mean? It means that the number that we're squaring is probably an even number. So let's look at the even perfect squares. So obviously there's 4, which is 2 squared. What about 4 squared? Does that work? No, that doesn't work. How about 6 squared? Does that work? 36? No. 8 squared? 64? That works. 10 squared? No. 11? No, sorry, not 11 squared. 12 squared. That doesn't work. 14 squared is not going to work either because it starts with a 1. 16 squared, 256? No. 18 squared, 324? Nope. 20 squared, that will work. 22 squared, that'll also work because that's 44. 24 squared, 576, that's not going to work. 26 squared, 676, not going to work. 28 squared, that's 784, that's not going to work. 30 squared, not going to work because we know it's 900. And that's it. So the answer should be 4. All right, so number 18. How many positive whole number divisors of 3,600 are either multiples or factors of 60? So you have to understand that a factor of 60 is also going to be a factor of 3,600, all right? So if a factor of 60 is going to be so we could make a Venn diagram. Let's just do it. Let's see. But the thing is, the only number that's going to be both a multiple and a factor of 60 is going to be 60 itself. But let's make it anyways. It always makes things easier to make a Venn diagram. So factors, multiples. So like I said, every factor of 60 is going to be a divisor of 3,600. All right. So how many factors of 60 are there? Again, we're going to, like in the last video I made, we're going to look at the prime factorization. We could quickly just dissect this. There we go. It's 3 times 2 times 2, which is 12. So that means there's 11 there. Now, how many multiples of 60 are divisors of 3600? So we just have to kind of look at it. What are we going to multiply 60 by? What are the different combinations of numbers that we can multiply 60 by? Because the thing is, we know that 60 times 60 equals 3600, right? So which numbers are going to be the multiples? We have to understand that we're going to multiply 60 by a number, right? We can multiply 60 by 1, we can multiply 60 by 2, 60 by 3, 60 by 4. But what are these numbers? What is in common with all these numbers that we're going to multiply 260 to get a divisor of 3600? You have to understand that they're also factors of 60. Now, this should become a big brain moment for you, because then you're going to realize how many multiples of 60 are there that are divisors of 3600. It's going to be however many factors there were, which is 12. Okay? So that means that this number is also going to be 11. So what's the answer going to be? The answer will be 23, because we're just going to add everything here. All right, number 19. Blah, blah, blah. I'm not going to read all this. Radius of the circle is that. 1 inch of the map is 10 miles in patch land. So this is 35 miles in patch land. Outside the quilt court. So let's say this is the quilt court. Everything else is not the quilt court. So everything else occupies 6/7 of the whole circle, which is pi r squared, right? Remember, area of a circle is pi r squared. Now, we know that this number is divisible by 7, right? And we know that there's an approximation of pi that people use, which is 22/7. So we're going to use that. Now we know the radius is going to be 35. So let's just quickly do this arithmetic right now. I know that 35 squared is 7 times 5 squared, so that's how I got that. Cancel that stuff out, and then this becomes 30. This becomes 110. The answer should be around 3,300. Closest number to that is 3,299. All right, number 20. Alexis added all the positive whole numbers from 1 to 2020. Bettina added all the positive even numbers starting from 2 also to 2020. What is Alexis's result over Bettina's result? So one thing you have to understand for the sum of the first n positive whole numbers is that sum will be n times n plus 1 over 2, which is also the formula for the nth triangular number. And this is basically derived by just simply taking the first number and the last number, pairing them up you just got to pair that up. You're going to pair 2 in 2019, 3 in 2018, so you keep going, so on. And how many pairs can we make? 10, 10. So 10, 10 times 2021. That's the same thing as 2020 times 2021 over 2. So that's why this works. But we have that, and let's call this A. This is going to be B. B is just 2 times 1 plus 2 plus 3 plus all the way up to 10, 10, right? Which is 10, 10 times 10, 11 over 2. Now, if we multiply that by 2, the 2's cancel out. So we have this divided by that. That's going to be A over B, which is what we're trying to look for, right? So those cancel out there, so then our answer will be E. Number 21 was the value of 77,773 times blah, blah, blah. This is, so if you look at these two numbers, these are obnoxiously close to one single number, which is that, right? Now we can kind of do some rewriting. What do we see here? We can actually, we just rewrote this as a difference of squares. So this is going to be 77775 squared minus 2 squared plus 4, which cancels out, by the way, over 9. Now we know that 9 is equal to 3 squared. So this is going to be square root of 77775 squared over square root of 3 squared. We know that square roots cancel out squares. So the answer will be this number over 3, which will give us that. How many 4-digit positive whole numbers have digits that sum to at least 32 with 3 digits summing to at least 26? All right. So for the digits to sum to at least 32, we're looking at 8888 type of stuff, right? But the thing is, we can't have 8888 because of this rule here. So we have to go 9986 because this works. This does what we want it to, right? And then we could do 9995. Can we do anything else? Yeah, of course we can. This is just for a digit sum of 32. So if we did digit sum of 33, then we'd go 9987 and then 9996. Now we can rearrange this in 4 factorial over 2 factorial ways, which is 12. We can rearrange that in 4 ways because we can either put the 5 here, 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 or here. This is going to be same as this. It's 12. This is going to be 4 as well. All right. Well, a digit sum of 34. We can have 9988 or 9997. It's going to be 4. This will be 6 because this will be 4 factorial over 2 factorial times 2 factorial. In other words, 4 choose 2. And for digit sum of 35, there's really only one way to do that. Well, not one way. It's going to be 4 ways. But really these all had like 2 different types of numbers, right? But this one will only have 1 type of number. And then, of course, we have digit sum of 36. It could be 9999. So that's 1. So if we add all of this, 1 plus 4 is 5. 5 plus 10 is 15. 15 plus 16 is going to be 31. And 31 plus 16 is going to be 47. All right, isosceles trapezoid has AB 13, BC, DA 6 root 2, and BCD is 135. All right. So the thing is about isosceles trapezoids is that, or the thing about in general for trapezoids is what we could do is we can separate it into a rectangle and 2 triangles. But since this is an isosceles trapezoid, we're going to know is that this part and this part is going to be the same. Okay. And then since you know that this is a rectangle that you just made, this is going to be a 45-degree angle. This is also going to be a 45-degree angle. And for 45, 45, 90 triangles, we're going to see an x root 2. So it's going to be like x root 2 type relationship. So that means this is going to be 6. This will also be 6. This will also be 6. And now since this is 1, or since this whole thing is 13, this is going to be 1. So AC squared. Now, you might not see it, but I see it. I see this whole thing right here. Let's call this point P. And let's call this point Q. I see that APCQ is one rectangle, right? And the diagonal is going to be AC. Now, how do I find that diagonal? I just use Pythagorean theorem for this rectangle with a height of 6 and a width of 7. Now, it says, what is AC squared? AC squared is just going to be AQ squared plus QC squared, which is going to be 6 squared plus 7 squared. So that means the answer is going to be 85. All right, so that goes through like 23 of the questions. Now, if you're getting 23 of the questions right, that's a score of 92, which for this test, for how difficult it is, I think it's a really good score. Of course, I could go through a lot of the other questions, but I think you're kind of better off looking through the solutions and doing it on your own, because that will be the best practice. So that will be it for today. I hope you learned something. I hope you got through my strategies. I focus less on memorizing stuff. I focus more on understanding stuff and just using the smallest tricks to try to get as much time as I can squeezed out so I could spend more time on the hard questions. And focus on getting questions right. Don't focus on trying to answer more questions, because accuracy matters more in the sprint round. Because the score is calculated by you're multiplying your correct number of answers times 4 and minusing your incorrect. So the more you get incorrect, the less of a score you'll get. So best of luck if you're taking any future Math League contests, and hope this helped. And I hope you have a great day.